Hello everybody and welcome back. We're looking now at question number 3 on the Galois paper. That's the grade 10 written paper from 2005. Two identical rectangular crates are packed with cylindrical pipes using different methods. Each pipe has diameter 10 centimeters. A side view of the first 4 rows of each two different methods of packing is shown. So just sort of a straight rectangular packing, 2, 4, 6, 8, 10 across, and then not quite rectangular, although sort of still grouped together, but we're allowing the cans not to rest directly on top of one another, but to sag in between the two. 2, 4, 6, 8, 10, and then 2, 4, 6, 8, 9 in the middle there. Okay. So I think I understand this one a little bit. We got 3 parts here. A, if 200 pipes are packed in each of the 2 crates, how many rows of pipes are there in each crate? Explain your answer. Okay. So it shouldn't be too difficult. We explain how the rows come together and how many are going to be in each row. And we should get 200. I would bet that it's an even number of cans. You won't have like some row with a little bit extra left over. So that's not bad. Let's, while we're here, read B and C. 3 pipes from crate B are shown. Determine the height h of this pile of 3 pipes. Explain your answer. So we're probably moving towards calculating the total heights in the crates or something with 200. C, after the crates have been packed with 200 pipes each, what is the difference in the total height? There we go. That's what I thought. Difference in the total heights of the 2 packings. Explain your answer. So the method by which we calculate this height h for these 3 pipes, we will generalize a bit here. We'll do B and C. Actually, I don't think we can really do B and C together, but we'll do B and that'll lead quite nicely into C. But for now, let's just do A. So if the 200 pipes are packed in each of the 2 crates, so we got crate A and crate B. Notice that in each row, in crate A, there are, not 20, there are 10. What is it? Cans or something? Pipes. Okay. There are 20 pipes. This means 200 pipes fits into exactly 200 pipes over 10 pipes per row, 20 rows. Okay. Now, crate B is a little different. Crate B has a row of 10, then a row of 9, then 10, then 9, and so on. So I imagine the 200 pipes will also fit evenly. 10 plus 9, so 2 rows at a time. Two rows together is 19 pipes. So there will be 200 over 19, 10 rows of 10 sort of, not rows, but double rows. Of 19 pipes. So 20 rows of pipes. With 20 minus 19 times 10, or 20 minus 190, or 10 pipes left over. These form the 21st row. Okay, because it goes 10 to the 9, 10 to the 9. So if we have 20 rows, the 19th will be a row of 10, and the 20th will be a row of 9, and so then the 21st can be a row of 10 again. There are other ways to explain this, some that you might find more sketchy, some that you might find less sketchy, but all the ingredients are there. The only thing that I think we might want to add is explaining why these 10 form and not 9 of them form the next row. But it's very quick to say 10 is for the first row, 10 is for the third row, so odd-numbered rows get 10. But I'm not going to add that in. I verbally explained it to you guys. If you want to add that sort of thing in, or if when you tried this question you did add that sort of thing in, that's great. But I'd say the pattern is clear here. Okay. So we'll just summarize, because they wanted the number of rows. So crate A, 20 rows. Crate B, 21 rows. Alrighty. So this will help us when we can, because at the end, ultimately for C part, we want to get the heights of the crates and then get their difference. Very easy to get the height of crate A because each pipe has a diameter of 10 centimeters. 20 rows is 200 centimeters. It's crate B that is the challenge, and that's why we have B part here to break things up ever so slightly. So I'm going to copy this little picture of the three crates, or of the three pipes together down in the notebook. So I'm going to notice two things. A diameter of 10 means 5 for the radius. The other thing I notice is the pipes are tangent to each other. Okay? And whenever I see points of tangency, I always connect them up to the centers. So a 5, a 5, a 5, a 5, a 5, and a 5. But we want the total height h here. And how can we get that? Well, look at these other radii. So we know h is going to be these two 5s plus, well, what do we need here? We've got a triangle, an equilateral triangle here. If we drop a height, I don't know, let's call it A for altitude. We might say h is 5 plus A plus 5, or 10 plus A. So as soon as I can figure out this height, I'm all set. So what is A? It's the altitude of the equilateral triangle of side length 5 plus 5 equals 10. Okay. Do we especially need to justify why this is a triangle? No, we should be fine there. Yeah, looks like we're all set. Largely, you could say it's a triangle just because of symmetry if you wanted to add that. Or I'm sure there's some little circle theorem you could do there. But no, we don't need to justify it. It's clear it's an equilateral triangle, so let's just draw a bigger version of our equilateral triangle, and we'll figure out what A is. So we want A there. Now, since it's an equilateral triangle and altitude splits the base in half, this isn't so much because it's an equilateral triangle, but because it is equilateral triangles are isosceles triangles. Okay. So we have 10 here. So if we take a look, maybe call it A, B, C. ABC is a right triangle. A here. So 10 squared is 5 squared plus A squared. Alternatively, if you know some trig or know that we've got 60 degrees here and 30 degrees up here, this is a 30, 60, 90 triangle. There's lots of ways to be able to tell that A is just going to be 5 root 3. One of them is, as I say, 30, 60, 90 triangles always have these ratios for the sides. Very common triangle. It comes up on contests every now and again. So 30, 60, and 90. So that's great. If you knew a little bit of trig, that would be fine too. Now, I don't suggest you have to know trig. It's the grade 10 contest, and at least when I was going through in Ontario, grade 10 is when we learned trigonometry. They don't usually throw that into the grade 10 contest. Fair game on the grade 11 contest, because you have definitely passed grade 10, or should have passed grade 10 if you're writing a grade 11 contest. So trig should be open to everyone. But this contest, the Galois, is written, it's in April, so not everyone has finished trig if they took it second semester, that sort of thing. So shy away from trig, but it's fair game if you know it to use it, but it's not required. All right, so we can just use Pythagoras here. 100 minus 25 is A squared, so 75 is A squared. A is square root of 75. Take out a 25, so we get 5 root 3. So H is 10 plus A, 10 plus 5 root 3. There we go. So we calculated their H pretty quickly, got ourselves an equilateral triangle, and this triangle came about simply from the tendency to, when you see points of tangency, connect radii to the centers of the circles. That is an instinct I always have, and hopefully it's an instinct I can slowly pass along to you guys, depending on how many of these videos you watch. Okay? But it's a great instinct to have. You see points of tangency, you connect them up. Not only do you connect them up, but you also, if it's a line that it's tangent to a circle, you connect it up and it makes a right angle. That's great to have as well. Okay, so, flip the page. We've got C part left to do. After the crates have been packed with 200 pipes, what is the total difference in the heights of the two packings? Okay. So, crate A has 20 rows. Crate A is not the one we need to worry about. It's not the one we're earning marks on. Crate B is the real challenge. That's the cheese. That's the one we want to be careful about. Explain everything, get the points. 20 rows, and each pipe has diameter 10 centimeters. So crate A is packed 20 times 10, 200 centimeters high. Okay. It's crate B that we need to work on. So, well, what are we to do? So it's not quite the same scenario that we saw. I'm going to draw a little bit of it, but, and these guys should probably be a little bigger. So crate B had 21 rows, not 20 rows. It's crate A that had 20 rows. So crate B had 21 rows, and then we sort of have something that looks a little like this. As I say, I'm not going to draw it all, but it's very similar to the look of B part for this question. But we have more than one row. B part was just between sort of two rows. So it keeps going on like this, and it would keep going down So we want the total height here. Okay, well this is going to be very similar to the height calculation that we made last time. I see a bunch of centers. So I can actually get a ton of these equilateral triangles. Okay, so I noticed that the distance between rows so the distance between centers of rows, so this little distance in here, not the distance, not the height of these two rows combined, but just the distance between these two rows is the distance between the pipe's centers, almost. Or the height between the pipe centers, let's say that. Because distance between pipe centers, you might think we go along the red lines, and so it'd be 10. So it's height between. And B, we saw this is 5√3 centimeters. So each of these little heights is 5√3. So to get the total height, we need to know how many of these 5√3s do we have. And then we need to not forget, we add on 5 for the height and the bottom. So between 2 rows, we had 1 5√3. Between 3 rows, we have 2 5√3s. Between 21 rows, we have 20 heights of 5√3. So H is 5 plus 20 times 5√3 plus another 5 for the bottom. I would even color code these if I thought it was necessary, but this is 10 plus 100√3. Okay, so now let's figure out the difference between these heights. So we're going to have 200 minus 10 plus 100√3. So why am I doing it this way? How do I know crate A was stacked higher? Well, one way we could do it is realize, well, this is 2 times 100, and this is 100 times √3. 2 is bigger than √3. So I'm sort of gambling that 10 doesn't make up more than the difference. Another thing we could do, √3, if you've seen a lot of this and worked it out with your calculator, you know it's about 1.73. 1.73 times 100, 173 plus 10, that's about 1.83. So there's the difference between heights. We can clean it up a little bit in that we can take away the 10, so we get 190 minus 100√3. And to verify that that is done the right way, we could even grab our calculators. Calculators are allowed. So 190 minus 100 times √3. I get 16.79. I'm going to include that. I'm going to say it's about 16.795. But the real answer is the exact one. That's the one we care about. You wouldn't just put the decimal. I'm putting the decimal just there to round things off and to show that I do sort of know what this number should be. And if you didn't have your calculator, if you remember that 1.73 is √3, what do we get? We get 190 minus 1.73, so that is about 16. You'll know that this is a little bit more, and so this will be a little bit less than 17. So you'd expect 16 point something. And that would be fine to put if you didn't have a calculator. But the real answer, 190 minus 100√3, that is the difference in the heights. It's not much, but it does show that crate B is the one that's packed a little better. Okay. Even though you might not think it because it loses a pipe per row, but it all works out fine. So we got one more question to go on the Galois. That's question number 4. Join me in the next video for that if you are so inclined. Feel free to like the video or subscribe or any of that fun stuff. And regardless, I will see you for more math in the future. Have a great day.